This is the last topic for section 1.6. We've been looking at solving absolute value equations. Today we're going to focus on absolute value inequalities. And it is really, really critical that you pay attention to whether it's a less than symbol or a greater than symbol, because they mean different things. If it says the graph of x, of the absolute value of x is less than 5, that means the distance from 0 has to be smaller than 5. So picture on a number line, we need to be from 0, we need to be closer than 5 spaces. So we could be 1 space, 2 spaces, 3 spaces, 3.5 spaces, all the way up to almost that 5. But we could also go in the opposite direction. We could be 1 space, 2 spaces, 3 spaces, 3.5, 4, 4.5. We can get almost to that -5 mark and still be smaller than 5 spaces from 0. So our statement here, the absolute value of x being less than 5, is the same as saying that our x's have to be in between a -5 and a +5. Now the only difference if there's an equal sign on it would be that we have equal signs on our expression and we'd have closed dots on our graph. But we are still saying we want to be within that 5 space mark from 0. So to simplify this statement, we have the absolute value of x being less than a. It's really just saying that our x value has to be smaller than the a value, the positive version of it, but bigger than, because it's on the bigger side of that symbol, bigger than the opposite of a, the negative version of it. Okay, so how is that going to look when we go to solve an equation or an inequality? The absolute value of 4x plus 3 has to be less than 5. That's telling me that 4x plus 3 has to be somehow in between the negative version of 5 and the positive version of 5. So we're back to having a compound inequality, and we can solve that treating it as if it were two separate statements. So to get our x by itself, the first thing we would do is subtract 3. We are going to do that on both sides because we really are looking at two separate inequalities. We're just solving them together. So now 4x has to be in between a -8 and a +2. To get x by itself, our next step would be to divide out the 4. We're going to do that to both ends of our compound inequality. And now we know that x has to be in between a -2 and a 1/2. There is no equal sign on this one, so we're going to have open dots. We're going to have an open dot at -2 and an open dot at +1/2. And we want all the numbers in between those. Now, yesterday we spent a lot of time checking our solutions. We can check this as well. We can pick a number that's in that shaded region. For example, let's say we pick -1. We could try and plug a -1 in there and see if it works. So the absolute value of 4 times -1 plus 3 is supposed to be smaller than a 5. We get -4 plus 3 is -1. Its absolute value is 1. Is 1 less than 5? Since that is a true statement, then we shaded the right part. Okay, let's try another one. 3x minus 4 has to be less than or equal to 8. So 3x minus 4 has to be somehow in between the negative version and the positive version. We want to be bigger. We want to be bigger than the -8, and we want to be smaller than the +8. Okay. To solve this, we're going to add 4 to all sides. 3x now is in between a -4 and a +12. And then we divide out our 3 to get x alone. So x has to be less than or equal to +4, but greater than or equal to -4/3. That's -1 1/3 if you're trying to place it on your number line. So we are about here and at 4. And we want all the x's that are in between those two numbers. Again, we can pick a number to plug in. For example, let's say we try this 0. It is shaded here, so it's implying that it's a solution. Let's plug it in. If we put 0 in here, 3 times 0 is 0, minus 4 is negative 4. The absolute value of negative 4 is 4, and 4 is less than or equal to 8. So it does work. So those are the and ones. We are saying that 3x minus 4 had to be less than or equal to 8 and at the same time greater than or equal to negative 8. Okay? So less thans or less than or equal to's, either of those, you are looking at trying to be in between. Okay, so you're going to have some expression that's in between the positive version of it and the negative version of it. All right, for the greater thans, now it's saying that we want the absolute value of x to be greater than 5. That means our distance from 0 has to be more than 5. So on our number line, I can be anywhere over in here, or I can be anywhere over in here. Okay? I just can't be numbers that are closer than 5 spaces to 0. Okay? So the greater than symbols, think of pointing out. You're trying to move farther away from 0 on either side. If there's an equal sign, like we have here, then we just put a solid dot. So our statement, we would say, x could be greater than 5 for that piece, or x could be smaller than negative 5. And again, the only difference here is that there's an equal sign. It is important to note that on the or questions, the greater, it's spelled greater than, like that, but think of it as greater. Okay, these are the or ones. These are pointing out, and they must stay as two separate inequalities. We cannot combine them into a compound inequality. So the absolute value of x being greater than a means that x could be less than the negative version, or it could be bigger than the positive version, since we have two separate chunks to our solution. All right, let's try one of those. So 2x plus 6 is greater than or equal to 10. Again, think of breaking out of jail. We need two escape routes. So 2x plus 6 could be greater than or equal to the positive version, or less than or equal to the negative version. Okay, we want to be going away from 0. Solving this, we have 2x. I'll go back a step here. Let's subtract our 6. So we have 2x is less than or equal to negative 16. When we divide by 2, we'd have x is less than or equal to negative 8. Or, on this one, subtracting 6, we've got 2x is greater than or equal to 4. And dividing, we have x being greater than or equal to 2. All right, so we want to be at 2 or higher, or we can be at negative 8 or smaller than that. So again, we're pointing away on our number line to the two opposite ends. All right, so greater, we're pointing outwards, and we have two separate statements. All right, we have to put these as separate inequalities with the word or in between. We cannot combine this like we did with the ands. All right, this does not work. Don't try to do that. All right, let's try another one. This one, notice that there is a guard. This +1, we need to get rid of it before we try to break out of jail here. All right, now we have a greater, so 5x plus 10 could be greater than 15, just like we see there. or 5x plus 10 could be less than the opposite of 15. Solving each of these, let's subtract our 10 and divide out the 5. We end up with x being less than negative 5. So that would look like that on our graph, from negative 5 on to the left side. On this side, we're going to subtract 10. So we have 5x is greater than positive 5. And then dividing out the 5, we have x being greater than 1. So open circle on 1 and shading to the right. So again, these are grators. They have to be two separate statements. The ones that we started with today, the and ones, are two statements that can be combined into one. Because again, we're looking for that overlapping part. Okay? We're still breaking out of jail. We still had two escape routes here. They just were kind of hidden. This was one of our escape routes, and this was the other one. Okay? So what I'd like you to do is to pause the video for just a second and try to match up the statement with what its graph would look like, and then come back on and we will check that. All right, so our first one says the absolute value of x equals 4. That means we have to be exactly 4 spaces from 0. Hopefully you chose option D, where we are exactly 4 spaces from 0. Question 2, the absolute value of x has to be greater than 4. That means we want to be farther than 4 spaces from 0. That should be picture A, where we are moving farther from 0. Here's 0. This would be farther than 4 spaces away. Question 3, the absolute value of x is less than or equal to 4. Less thans is an and situation where we put it into a compound statement. Okay, less than, think, kind of add a D on the end of that and think of it as less than. It is an and situation that we can combine into one big compound statement. So the absolute value of x being less than or equal to 4 means we have to be in between 4 and negative 4, which means we would need solid dots and shading in between those. That would be picture E. Question 4, absolute value of x is less than 4. We want to be closer than 4 spaces from 0. That would be option B. And our last one, we want to be greater than or equal to 4, so we want to be going away from 0, but we can actually be at 4 as well, so that would be picture C, where we are at 4 and anything bigger. We're at negative 4 and anything bigger. Okay? Sorry, anything smaller than negative 4. All right, the last little question that we're going to look at deals with something called tolerance. It's typically used when you are trying to make something a certain dimension, but you're willing to accept it to be a slightly off of what you would desire it to be. Okay? So tolerance is half the difference between the maximum and the minimum acceptable values. Let's look at an example of this. We want to cut a piece of wood that's 6 inches long, but we will use it if it's between 5.9 inches and 6.1 inches. This means that the length is anywhere between 5.9 and 6.1 inches. So to figure out our tolerance, we take our maximum allowed minus the minimum allowed, and divide that by 2. We want half of that amount. So we would take 6.1 minus 5.9, divide it by 2, and we have 0.1. So if you picture on a number line, there's 6. We are saying that we are tolerant of it being either 0.1 above that or 0.1 below it. So that gets us to our 6.1 or our 5.9 values. And we're okay being anywhere in between there. Okay? To write this as an absolute value inequality, we would say our total length, we're going to take away the exact number we want, and its absolute value is within 0.1. So if we think about that, L minus 6 absolute value is less than or equal to 0.1. Breaking out of jail, we would say L minus 6 has to be within the positive and the negative version of that. And adding 6 is how we're going to get our 6.1 and our 5.9 cutoff points. Okay, so our length could be anything in between those. So to write an absolute value inequality when we're talking about tolerance, you are going to say your variable minus your desired amount the absolute value of that has to be less than or equal to the tolerance. Okay, so our next example here, in car racing, a car must meet specific dimensions to enter a race. Suppose the desirable height is 52 inches, but cars will be accepted as long as they are between 51 inches and 53 inches. Write an absolute value inequality to describe the cars allowed. So this is our minimum. It's the lowest we can go. This is our maximum. So let's figure out our tolerance. We take max minus min and divide by 2. So 53 minus 51 is 2. 2 divided by 2 is 1. We are allowing it to be 1 inch above or below our desired amount. Okay? So to set up our absolute value inequality, we take our variable. I'm going to use an h for height. We subtract the exact value that we want, and we say we have to be less than or equal to our tolerance, which was 1. Okay? Again, if you check how you've set it up, breaking out of jail here, we would say h minus 52 has to be in between the positive and the negative version. Adding 52 to all sides here says our height has to be between 51 and 53, which is what we were told in the initial problem. All right, that wraps up 1.6. We will start reviewing and getting ready for our test tomorrow. Check Schoology for your assignment.